Okay, fourth lesson, we're just dealing with some more complicated problems in this section of the chapter. So to example 6, part A. It says find the coefficient of x to the power 4 in the binomial expansion 2 plus 3x to the power 10. Now I don't have to go all the way through it till I get to x to the power 4. You can notice something quite handy here. So it's going to be, the b is going to be the x term. So we want x to the power 4, so you're going to need b to the power 4. Now one thing you can spot is, look, b to the power 0, 0, b to the power 1, 1, b to the power 2, 2, b to the power 3, 3. So b to the power 4, whatever x term you're after, that's going to be on the bottom of the NCR bit of the coefficient. So for the fourth term, I know it's going to be 10, choose 4, and it's going to be 3x to the power 4. Then it's going to be 2 to a power. And what power is it going to be? Well, remember, these two powers must always add up to the overall power, so it's going to have to be power 6. Right, then I can work that out on the calculator. So I've got 10 choose 4, choose 210, I'll work this out individually. 2 to the 6, 64, 3 to the 4, 81. So 210 times 64 times 81, I've done times 80, times 81 is that big number there. So 1088,640 x to the power 4. So that's the coefficient. And be careful with that. If the exam question, if it does say find the coefficient of, and you left it as that x to the power 4, you're in danger of losing a mark. I would hope they wouldn't dock you a mark for that, but you never know, so just be careful. Part B. We've got 2 plus x times 3 minus 2x to the 7. It wants the coefficient of x cubed. So where's x cubed going to come from? Well, it's going to come from 2 times the x cubed term in the second bracket. It's going to come from x times the x squared part in the second bracket. So we only need to work out the x squared part and the x cubed part. So let's work them out in order. So let's work out the x squared part first. So power 7, and I'm just doing it this one. So power 7, so it's going to be 7 choose 2 minus 2x squared, 3 to the power of must be 5 because 2 plus 5 is 7. And set up the second one, it's going to be 7 choose 3 minus 2x to the 3, 3 from the first part to the power 4, because remember 3 plus 4 is 7. So let's work those out using the calculator. So 7 choose 2 times 3 to the power of 5 times 2 squared. Obviously I know that minus squared is going to be positive. So that's 20412 x squared. For the second one, 7 choose 3 times 3 to the power of 4 times 2 cubed, so obviously 8. And I know this one's going to be negative because that's negative. Minus 22680 x cubed. So in order to get the x cubed terms, it's going to be 2 times this one. It's times this one by 2. And it's going to be x times this one to give me x cubed. So that's going to be the same. So it's going to be 20412 x cubed. So in total I'm going to get 20412 x cubed, and I'm going to get this one times 2, 45360 x cubed. So we'll just do 20412 subtract 45360 gives me minus 24948x cubed. So that is the coefficient of x cubed. Obviously you can do it a longer way by expanding all that out to at least the x cubed term, but it's a bit of a waste of time. Right, example 7. Right, example 7 says we've got 1 plus kx to the power of 10. The coefficient of x cubed is 15. I've got to work out the value of k. We had a similar question to this earlier in the chapter. Now, it wants x cubed, so it's going to be 10 choose 3, kx to the power 3. So then it's going to be 1 to the power 7, which was largely irrelevant because 1 to the power 7 is 1. So that's going to be 10 choose 3. So 10 choose 3 equals 120. Now, common error here to put kx cubed, but it's not, it's k cubed x cubed. So that's the coefficient, which is equal to 15. So we get k cubed equals 15 over 120, which is 1/8, I think. So then cube root that, k equals half. That's quite an easy one. Another example on this chapter, example 8. Write down the first 3 terms of the binomial expansion 1 plus qx to the power 8. It wants first 3 terms. So again, it seems quite easy. So you can have 8 choose 0, which is 1, 8 choose 1, which is 8, 8 choose 2, which I'll have to work out in a minute, 1 to the power 8, 1 to the power 7, 1 to the power 6, but it's 1, so who cares? Qx to the power 0, don't worry about it. Qx to the power 1, Qx to the power 2. Right, so what was this 8 choose 2? So it's going to be 8 times 7 times 6, 5, 4, 3, 2, 1. But that's going to cancel with 6 factorial, which is going to go here. So what's that? 56 over 2, which is 28, I think. So it's going to be 1 plus 8qx plus 28 q squared x squared. That's quite easy, that one. Obviously it carries on, but it only wanted the first 3 terms. Part B. So it's given that the expansion of 1 plus qx to the power 8, which is what you've just done, the coefficient of x is minus r, and the coefficient of x squared is 7r. Okay, so we're told the coefficient of x is minus r, the coefficient of x squared is 7r. Alright, so that gives us 2 equations. We've got 8q equals minus r, and I've got 28q squared equals 7r. Well, first in the second one, if I divide by 7, I'll get 4q squared equals r. What am I trying to work out q and r? So, well, there's lots of ways of solving it. So if I say here minus 8q equals r, then I've got equals r, so I can just equate these two. I've got 4q squared equals minus 8q. If I divide both sides by q, can you say q is non-zero? Right, well, I better take this over just in case. So I've got 4q squared plus 8q equals 0. So I can take 4q out. Plus 2 equals 0. It can be 2 answers. Q equals 0 and q equals minus 2. But if I just divided both sides by q, I would have missed out this first solution that q is 0. But very often in the question it will say given that like Q and R are non-zero, but it didn't, I don't think. I can't see where it says that. So anyway, so if Q equals 0, then R equals 0. And then if Q equals -2, then we've got R equals -8Q. So that's -8 times -2, which is 16. So Q equals -2, R equals 16. No, we know the non-zero, because otherwise it'd be a pretty dull equation. You'd just be doing 1 to the power of 8, because if Q is 0, Q can't be zeros. You've just got the expansion of 1. Anyway, that is all the examples up to exercise 8D. So if you can now smash for exercise 8D and let your teacher know if you have any problems with any of those questions.